Our next lesson are the boat in the river problems that I've been telling you about all semester. So we're just going to dive right in. All right, they're not as hard as maybe I had mentioned before, but it is a lot of different variables. In these equations, there are 6 unknowns, and so sometimes that part gets a little tricky. But basically, there'll be a problem that sounds like this. Robert and Clay could go 60 miles downstream in the same time that it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of their current and what was their times? So see, it just sounds a lot confusing, but here's how we're going to break it down. First, we have to realize that a boat that's going downstream, we're going to use D for downstream, the rate of the boat going downstream, the downstream rate, is going to be equal to the rate of the boat plus the rate of the water or the current. So if you're in a boat and you're going downstream and you turn the motor on, and let's say you turn the motor at 20 miles per hour and the water is moving at 4 miles per hour, then your downstream rate is going to be 24 miles an hour because it would be the rate of the boat plus the rate of the water. Now the upstream rate, it's harder to go upstream because you're going against the current. So the upstream rate is the rate of the boat, but then you have to subtract the rate of the water or the current. So in this same case, if the boat was going 20 miles per hour upstream, but then the current, they're going against the current. So the current, we have to subtract that. If the current is moving at 4 miles per hour, then the upstream rate would be 16 and the downstream rate would be 24. So that's how you figure it out. You have to use the rate of the boat plus the water and the rate of the boat minus the water. So then that gives us 2 different equations. You remember that distance equals rate times time. So in this case, the distance downstream is going to equal the rate of the downstream. And in this, remember, the rate of the downstream is B plus W. So it's going to equal the rate of the boat plus the rate of the water times the time that it took them to go downstream. Okay, so that's our downstream equation right there. The upstream equation is going to look like this. Our upstream equation is going to be that distance upstream is equal to the rate upstream. Now remember, the upstream rate is the rate of the boat minus the rate of the current. So we have B minus W, and then that's multiplied by the time upstream. So here is our 2 basic equations, our downstream distance and our upstream distance. Okay, so let's move that up here, and let's try a problem. Okay, we're going to keep these equations so that we can see them. All right, in this equation, Robert and Clay could go 60 miles downstream. So the distance downstream equals 60 miles. Okay, we're just going to leave it at 60 right now instead of putting in the unit. What else does our problem tell us? It says that it took them the same time to go 60 miles downstream as it took them to go 20 miles upstream. So our distance upstream equals 20. They want us to know now both the speed of their, it tells us, sorry. If the speed of their boat was 8 miles per hour in still water, so that's the rate of the boat. The rate of the boat equals 8 miles per hour in still water. Now they want to know the speed of the current, which is W, or water. We need to figure out what the speed of the current was, and what was the time it took them to go downstream, and what was the time that it took them to go upstream. So those are the 6 variables that I was explaining before. In these boat and the river problems, we have the distance upstream and the distance downstream. We have the speed of the boat and the speed of the current, which is W, or water. And then we have the time it takes to go downstream and the time it takes to go upstream. So here they give us 3 of the variables, and they want us to find the other 3. So basically, we can use elimination with these, or we can use substitution, whichever one you would rather do. So let's put in what we know. We know that the time is the same because it said Robert and Clay could go 60 miles downstream in the same time that it took them to go 20 miles upstream. So our time downstream is equal to the time upstream. So for the sake of this problem, we're just going to call the time just t. Okay, so now let's fill in what we know. Let's try this equation. We know that the distance downstream, which is 60, equals the boat, which we know, which is 8, plus the water, we don't know that one yet, and times the time. And remember, the time downstream, the time upstream is the same, so we're just going to call it t. Okay, so that's one equation. Another equation that we know is the distance upstream. We said that they could go 20 miles upstream. So we have another equation here. We have 20 equals the speed of the boat, which is still 8. This time we have to subtract the speed of the current, which we don't know. And we're going to just call this t because tu equals td. So now if we use, sorry, I can't think of the word. If we use the distributive property, our equations look like this. 60 equals 8t plus wt, and 20 equals 8t minus wt. Okay, so now if we look at these two equations, we see something that we can do. If we use elimination and add these two equations together, the wt's will cross off, which will make it really easy for us. So we're going to move this equation, 20 equals 8t minus wt over here, and we're going to add those two together. 60 plus 20 equals 80, 6 plus 16t, and then those cross off. So basically we have that 80 equals 16t, divide each side by 16, and t equals 5 hours. So we figured out one of our variables, or actually two, because the times were the same. So we know that this time d equals 5 hours, and the time upstream equals 5 hours. So the only equation left we have, the only thing we have left to solve is w. So we're going to put this 5 back in for one of our equations. So let's put it in for this one. We're going to substitute, we're going to put 5 in for t in this equation right here. So that gives us 60 equals 8 times 5 plus w times 5. 60 equals 40 plus 5w. Subtract 40 from both sides. 20 equals 5w. That means that the water is moving at 4 miles per hour. So there you go. We solved everything. We know the two distances. We know the speed of the boat is 8. We just figured out the water is moving at 4 miles per hour. And we figured out the times were 5. So not too hard. We'll try one more just to make sure that you have it. This one says that the steamboat could go 70 miles downstream. So I'll move my paper back here. We can move 70 miles downstream. So the distance downstream equals 70. And in 5 hours, so the downstream time equals 5. But it required 6 hours to go 48 miles upstream. So the distance upstream equals 48, and the time required to go upstream equals 6. What was the speed of the boat in still water? And what was the speed of the current or the water? Here's our 6 variables, and in this case we know 4, but we don't know 2. So we're going to begin by writing both of the variables both of the equations that we know. Our downstream equation, the speed of the boat plus the speed of the water times the time it takes to go downstream equals the distance to go downstream. Basically, that's distance equals rate times time. This is both of the rates combined.